Hello and welcome. My name is Deepak Bhatta. I am a assistant professor in Department of CSIT, and today we will discuss the important questions that is asked in the graph theory, that is Euler formula for planar graph and the chromatic number with example. So as you can see here, the question that is asked in the exam: what is Euler formula for planar graph and what is the chromatic number of Kmn and Ka, explain with example. So let's jump on to the topic, that is Euler's formula. So basically, how can you define the Euler's formula is Euler formula is a fundamental theorem in the study of planar graph, which are graphs that can be drawn on a plane without any edge crossing. So means we cannot cross the edge between two edges. So we cannot cross the edge in any graph, that is planar graph. So here I am showing the example. So let us consider this A as a node and B as another node and C and D are another node. So if I put this edge from A to B and from A to D, then I want to move from B to C. This point is a crossing point. So planar definition states that we do not cross any edge between two edges. So here we can find out we are crossing the edge A to D and B to C. So instead of it, we can construct the planar graph as we can construct as, or we can connect B and C from outer side. So this is a planar graph. So none of the edges are crossing with each other. So this can be called as a planar graph, right? So here in the given question they ask what is Euler formula for planar graph, right? So we need to find out the Euler formula for planar graph. So first of all, you need to define it as a Euler formula is a fundamental theorem in the study of planar graphs, which are graphs that can be drawn on a plane without any edge crossing. So the formula states that for any connected planar graph, B minus E plus F equals to 2. So we must get this 2, then only the graph can be called as a Euler graph, or we can call it as a Euler formula. So here B represents the number of vertices, E represents the number of edges, and F represents the number of faces. So B is the number of vertices and E is the number of edges. So example of Euler formula. So here consider a simple planar graph such as a cube. The cube has 8 vertices and the cube has 12 edges and it has 6 faces. So by applying the Euler formula, B minus E plus F, that is 8 minus 12 plus 6, it is 2. So this satisfies the Euler formula. So we need to construct we need to find out by using vertices minus edge plus faces equals to 2. So this is the Euler's formula. So we get this 2. So we get this 2 over here, right? So let us take this example. So we have 8 vertices. So here I am 1 vertex, 2, 3 and 4, 1, 2, 3, 4. So they are connected with each other. So draw such that so no two edges can cross each edges. So here none of the edges are crossing each other. So this is our planar graph. So as you can see that we have 1, 2, 3, 4, 5, 6, 7 and 8. So B equals to 8. We have 8 vertices and we have how many edges? So here, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So we have total edge equals to 12. So we have 12 edges. So faces. So face is for the face. So this is 1, this is 2, this is 3, this is 4, this is 5 and this back side or this side represents as the 6th edge. Sorry, face. So for simpler, here you can see this is 1 face, this is 2 face, this is 3 face, this is 4 face and front side this is 5 and back panel side that is 6. So there are total 6 faces. So here we can also construct this 6. So F equals to 6. So how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. And how many edges are there? So there are 4, there are 4 and there are 4. So 3 4s are 12. So we have 12 edges, right? So now move on to the next, that is chromatic number. So how can you define the chromatic number? In your given question they ask what is the chromatic number of Kmn and Ka. So first of all you need to define what is chromatic number. So the chromatic number of a graph is the minimum number of colors needed to color the vertices of the graph so that no two adjacent vertices share the same color. So we do not assign the same color between two adjacent. So we can call the complete bipartite graph using chromatic number, that is Kmn, that is 2. So we must have at least 2 color. So we must have 2 color for satisfying the chromatic number of a complete bipartite graph. So let us take an example. So let us take sorry. So k mn, that is k 3 2. So I need to construct the complete bipartite graph of k 3 2. So these are the two subset having 1 2 3 vertices on the one subset. On the other hand, we do have two vertices on another subset, so 1 and 2. So connect to this node with other subset of vertices, so this with this and this with this with this and this with this. So this is a complete bipartite graph. So complete bipartite graph. Bipartite graph, right? So we have just constructed k 3, 2 complete bipartite graph. So we need to fill two colors. So no two vertices have the same color. So we need to keep in mind that no two adjacent have same color. So if I fill, so let us assume that okay, let's take blue. So if I fill this as a blue, then I cannot fill this another subset vertex, that is this node, as a blue. So this violates the property of the chromatic number in the complete bipartite graph. So let us fill another color, that is yellow. Let us fill this as a yellow. Now, so I cannot fill here and here yellow. I cannot fill here yellow. So this and this are the adjacent. So this and this are the adjacent. So adjacent, no two adjacent vertices the same color. This is our rule. So I can only fill this, sorry, this as a blue color and this as a blue color, right? So this blue, right? So we just finish the definition of a chromatic number of complete bipartite graph as, so we have a blue color here, blue, and we have another subset that is yellow. So we just use two colors. So this defines that kmn equals to 2. So we must use two color. One subset have one color and another subset have another color. So in the exam you also need to construct or show like this example. So here the definition of a chromatic number of k mn as, the graph mn is a complete bipartite graph where the vertex set can divide into two disjoint subsets. So let us assume this as a u1, u2 and u3, one subset vertex, and this can be v1 and v2. So can be divided into two disjoint sets u and v, such that u has m vertices and v has n vertices. So we have u has m vertices, this is u have m vertices and v has n vertices. So u have 3 vertices and v have 2 vertices. So every vertex in u is connect to every vertex in v. So we have u1 is connect with v1, u1 is connect with v2. Likewise u2 is connect with v1, u2 is connect with v2, and likewise v3 is connect with v1, u3 is connect with v2. So we satisfy the conditions of chromatic number of Kmn. So here observe this point, this is because a bipartite graph can be colored with two colors, as there are no edges between vertices within the same set, right? For 3k 3,3 you can use two color to color the vertices in set u and v. No two vertices within same set are adjacent, so only two colors are needed. So let us take this k 3 3. So we need to construct 1 2 3 in a one subset and 3 on the other subset. So this is a complete bipartite graph. So we need to construct from this to this, this to this, this to this, and no two adjacent share the same color. So if I put this as a blue and we cannot place this as a blue, so there must be a different color. So no two adjacent share the same color. So let us fill the color as blue, and I cannot put this as a blue, this blue, this blue. So there must be a different color. So in one subset there must have a same color, that this is one subset and must have same color, and another subset there must have another color. So we have only two color to be filled in k3, 3, right? So let us discuss about the chromatic number of Ka. The graph Ka is complete graph with a vertices where every pair of distinct vertices is connected by an edge. The chromatic number of Ka is, that is A. So if we have the K4, then we must have 4 color. So this is the theory that the K4 equals to 4. We have 4 color for the K4. So this is because in a complete graph every vertex is adjacent to every other vertices, so each vertex must have a unique color. So here we must have a unique color. So let us take the example for K4. You need 4 different color, one for each vertex, since each vertex is connected to every other vertices. So take the example that for the easiness I will draw the 4 vertices in the graph, that is K4. For the K4 we have 4 colors, right? So this is connected with this, 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 this is connected with this. Is a complete graph. So this is a complete graph. So we have 4 vertices, v1, v2, v3 and v4. So if I put this color as green color, then I cannot fill V2 as green, nor V4 as green, nor V3 as green. So there must be a unique color. So I can only put this V2 different color. So if I place this V2 as red, then I cannot fill this V3 as red and V4 as red. So they are, so no two adjacent have the same color. So if I have K4, then I must have at least K4 color. So so let us take the yellow. So if I put here yellow, so I cannot put this here yellow. So take the another color, that is blue. So blue. So here we fill 4 color for K4. So here we have filled 4 colors for K4 graph. So K4 is a chromatic graph, that is 4. So K4 must have at least 4 color, right? So this is the example. So in the exam you also need to construct this to get a full marks. So construct like this. So thank you so much for listening. If you enjoyed this video and want to see more on variety of topics, please hit the subscribe button. I am always creating new content on C programming, operating system, Java programming, PHP programming, HTML, CSS and JavaScript, computer architecture and many more of IT subjects. Please do subscribe.